Hey, in this tutorial we're going to be looking at trig identities using reciprocal trig functions. So we've just got a few identities to look at first, and then we're going to use those to do some proofs with trig identities. So one of our first ones is just some notation. So sine of theta all squared, okay, is equivalent to sine squared of theta. We just find it's a bit easier to write it in this form because unless we put in these other brackets, if we've got a squared there, well, do we mean the whole function squared or just the theta? What is it that we mean? Okay, so the easier way to write it is with our squared, with our sine. Same goes for cos or tan. Okay? One of our fundamental identities is sine squared theta plus cos squared theta equals 1. And we also know, and we've seen this before, that tan of theta equals sine of theta divided by cos of theta. Now it's just a little note there that theta cannot equal 2n plus 1 times pi on 2. That's basically our values for theta, in which cos equals to 0. Okay, and when cos is equal to 0, then tan becomes undefined, and that's where we get our asymptotes for our tan graphs. Okay, we also should remember that tan of theta equals sine of theta divided by cos of theta, and as we introduced in the last video, that sec of theta is 1 on cos of theta, cosec of theta is 1 on sine theta, cotangent or cot of theta is 1 on tan of theta. And a couple of new ones that we're introducing in this video is 1 plus cot squared theta equals cosec squared theta, and tan squared theta plus 1 equals sec squared theta. Now you can actually, at the end of this video, if you like, actually prove these ones for yourself, okay, because it's a rearranging of this equation here. Okay, for this one, we need to divide it by this equation by sine squared theta. And for this equation, we divide this identity by cos squared theta. So that's dividing each term. Okay, so I'll let you have a look at that at the end of the video yourself, because as you'll see in a second, we're going to look at how we actually go through a proof. Okay, so we've got two proofs that we're going to look at, and this is our first one, which is prove the identity tan theta plus cot theta equals sec theta cosec theta. Okay, so that means that these are times together. Okay, so the way we need to go about proofs is that in order to prove an identity like we have here, we need to show that this side of the equation is in fact equal to this side of the equation, or vice versa. So we just need to modify one of the sides of the equation and make it equal to the other side of the equation. Therefore, we're proving that they're the same thing. So we're going to start by looking at our left-hand side. Our tan theta plus cot theta. Okay, so we need to think, well, what do we know about our tan? Well, from previously, we know that tan of theta is equal to sine theta over cos theta. Okay, and we also know that cot of theta is equal to cos of theta over sine of theta. Now that's purely because cot is by definition 1 on tan. Okay, so that means that we can actually just flip these over. Okay, so our left hand side, this side can be written as sine theta over cos theta plus cos theta on sine theta. Okay, so that's our left hand side. Okay, so if we look at adding our fractions, okay, here what we're going to do is get a common denominator. So a common denominator is going to be when we're multiplying these two together. Okay, and then we've got to cross multiply as well. So we end up with sine squared theta plus cos squared theta over cos of theta sine of theta. Okay, so we just need to remember too that now this top line sine squared plus cos squared we can write that as equal to 1. So 1 over cos of theta sine of theta. Okay, so remember what we've done here, from this step down to here, we need a common denominator, find that by multiplying these together, gives us our cos theta sine theta. Okay, and then we look, okay, what do we multiply our cos by to get cos theta sine theta? Well, it's times by sine, so we're going to multiply this by sine, and similarly, we need to times this sine by cos, okay, in order to get this. Okay, so we're multiplying our cos's together as well to get our cos squared theta. Okay, so we're now down to this stage. Okay, so then we can think, well, our left-hand side, okay, we're going to come up here now, well, we can actually split that up a little bit, and we can just think of that as well. We know that that's got to be equal to 1 on cos of theta times 1 on sine theta. So all we're doing is splitting that up a little bit, because 1 on cos is equal to sec theta, okay, and 1 on sine is equal to cosec theta. Okay, so this process, and as you can see, we've ended up with what we had over here. Okay, so we're showing that our left-hand side here does in fact equal this, okay, by this manipulation. Now, it can be hard to actually think about, well, these steps that we could have to do. Okay, sometimes you just need to play around a little bit until you kind of stumble across things, but don't forget that you know what you've got to get this side to equal. It has to equal this side. Okay, so always in the back of your head go, okay, well, how else can I also write these? Okay, and that's our 1 on cos and 1 on sine. Okay, well, how can we end up getting to that from here? So you can always go back a step from these, and instead of trying to make this here equaling that, it might be that you try to make this equal this part, just so you can see those links a little bit more. Okay. So we'll have a look at our next proof, okay, which is prove that 1 plus tan squared theta divided by 1 plus cot squared theta is equal to tan squared theta. Okay. So again, we need to think back to the identities that we have. Okay, so we think of this left-hand side. Okay, this is the side that we're going to manipulate. Okay, remember that 1 plus tan squared theta, well, that's equal to sec squared theta. That was one of our identities that we introduced before. Okay, and that 1 plus cot squared theta is equal to cosec squared theta. So again, they're both our identities that we used earlier. Okay, so then we can say, well, this left-hand side, and notice how I'm just saying left-hand side, I'm not writing all this part out again, I'm just saying left-hand side. Well, we can write our left-hand side, then our top line is sec squared theta over cosec squared theta. Okay, so remember that sec squared, okay, well, that's equal to 1 over cos squared theta, and that cosec squared theta is equal to 1 on sine squared theta. Okay, so now we can think, okay, our left-hand side, so again, I'm going to come back up here, our left-hand side, okay, we can think of it as 1 over cos squared theta over 1 over sine squared theta. Okay, and think, okay, then we've got one fraction, we're dividing by another fraction. Remember then that is just flip and multiply. So saying that we've got 1 on cos squared theta times by sine squared theta on 1, which gives us our sine squared theta over cos squared theta. Okay, sine on cos is tan, which means sine squared on cos squared is tan squared theta as required. Okay, so again we'll just use some of our identities that we knew, okay, to end up proving this. So remember I said earlier, okay, to go back and have a look at actually coming up with these two proofs, okay, by manipulating this. So that's something that you can probably do as a little bit extra, but hopefully with what we've done with the two proofs here, that'll give you enough to have a crack at the questions from this section.